Hello everyone, I'm Xiaogang. In these few sections, we'll start talking about encapsulating this third-party library plugin. This knowledge is extremely important, extremely important, extremely important, extremely important. How important is it? Let me tell you, the knowledge I cover in these few sections alone is more than enough to make this course worth its price. It means that when you're at work, you'll encounter situations where the team you're collaborating with might not be from the same studio or the same project group. They might not even be using Unreal Engine, they could be using C language or C language. It's C++, and when they provide you with code resources, they usually provide them in the form of header files plus libraries, or in an internal manner, leaving aside the company aspect. When we work on our own projects, we will use a large number of open source resources from the community. Some of these resources provide source code, some provide libraries and header files. But there is a problem. If they provide a source code, you'll find that you still need to compile this source code yourself, and you have to compile it once. Moreover, when you bring it into UE5, it may not even be able to compile successfully, but if it directly provides such third-party libraries and DLLs, then we can directly integrate them, and we can use them. So what are the typical application scenarios? For example, our WebP, or eFlycus, Alibaba Clouds, and ByteDance's, Piston Engines, Baidu's, all of these can be integrated in this way, integrated into UE5 for combined use. Therefore, the last few sections of resources in this chapter are very code-heavy and very important. And if you search online, actually, no matter how much you search, many people haven't really explained this thing clearly to you. How to do this thing. Why do it this way? You often run into this library can be imported. After importing this library, it won't compile. Then the editor works, but it can't be packaged. After packaging, it won't run. Then this problem appears. Then that problem appears. So it's quite obvious. You haven't followed the standard process at all. So this is extremely, incredibly, and if you search for this resource across the entire internet, many people have talked about it. They all have their own different approaches. But this approach of mine verified by me after I completed it, and it works. Packaging is also completely fine. So now I'm going to teach you this knowledge. So it's very important, very important. Then we'll actually put it in a later chapter. In this section, we've only covered the native ThirdParty. And then here let me go over the official documentation with everyone again. So for this name, we'll just call it Xiaogang. ThirdParty, break. Okay, then for the seeded character, it's still Xiaogang. Then we just check this box. We won't cover the game feature here. Let's move it further back. Because this project schedule, this course's schedule is already very tight. Okay, good. This part has succeeded, and this thing pops up. It popped up a Windows library dialog. You can ignore it. We need to turn this off here. Then let's reload it. Now let's come in. Come to the plugin it generated for you. Have you noticed? It has written a lot of things here. Right, don't worry, ignore it. Completely ignore it. Let me talk about this here. Now let's compile. It will definitely be fine. Compile it. Let me explain how this code is structured. Obviously, this is a standard third-party library architecture for Unreal Engine. First, there are still plugins, but after the plugins are imported, everything else remains the same. Resource, intermediate, content, bearers. The difference is that there is a seller party here, and here there is this is the module name of our project. Then inside seller party, there will be a dedicated third-party library. So this is the libraries. There are so many things here. Don't look at all these things for now. Because we will delete them, because some of them are redundant. So you can know this is where third-party libraries are placed. Recall this is a project suite, a project, so it's relatively complex. So this place is generally where third-party libraries are placed. And then this is where we exposed to other Unreal modules for them to call, the location where this is executed. Okay, after understanding this point, let's continue looking further down. Let's look at this first. Exposed to other Unreal Engine projects, something to be used. So obviously this is a build module. Then what is this module? This is the accompanying third-party libraries module. We call it the external reference module. We can call it. Then there is no other difference at all. Okay, so this is equivalent to our plugins main module, the plugin's main module. And you will find that this does not include this. third-party library module. We call it the library module, and because the library module, it is a module that is external. This external refers to an external thing. It is actually not a real module. So you can see the module we are trying here. Is this rule? Yes, okay, let's just ignore it. This is the rule from EDMONDU. If you are interested, you can go. The official documentation also explains. The previous official documentation explained it. I haven't checked the latest one yet. Not sure if it's still there. Actually, I don't really care. Anyway, just know that you need to explicitly include it. You just need this header file. Then, what do we need to do? Here, and this is our main module. In the main module, this is called the library handle. This is the handle of your DLL. The handle of the DLL. When you load the DLL, it will store a pointer here, pointing to this DLL. In the start module, don't look at these. Definitely don't look at them. Looks too complicated. This part is to find the path of this DL. So if there is a Windows version, it looks for this. Because this is cross-platform, there are Mac and Linux. So on different platforms, the format of the third-party library you use is different. So they are uniformly placed in these locations. You should not copy his code exactly. His third-party library plugin is well written, but if you write it exactly as he does, it will cause problems with what you make. It won't be usable, but you can refer to it and learn from it. So this part is to find the path of this library. Then if this mirror path exists, we will load it through this platform. That's the idea. Okay, then here we record this handle. After recording the handle, when we close the module, we release it and set this pointer to null. So that's the process. Then after loading, you can call the method inside it. Obviously, this method definitely requires a header file. Do you know what methods are inside? If this side loads successfully, if this side fails to load, it will pop up a dialog box here. This means that the loading failed here. And if this side loads successfully, it will call this method. Where is this method? Let's click in. This method is, we call it here, right here. That is, the header file is this method. This method has a lot written in it. So much written. You can ignore it for now. We'll modify it later. These are all some default writing methods. That is, if you are making a third-party DLL, you can use this method to write it. And this place is on Windows removes a message. Win32, Win64, remove a message. To pop up this box, popping it up is a third-party plugin. Okay, so actually this is its architecture within the project. It's roughly like this. You can see, and then this Build.cs, we call it label it. What work is it supposed to do? Because of your third-party library, generally there are two ways. One is to store DL, store label. One is label plus DL. That is store label. It is equivalent to the original text, putting everything together. You compile everything in, and this kind of label plus DL means you have to work on both label and DL. Because label only compiles the header into it. Okay, so this part is label. Its function is to first, it takes some commonly included paths and specifies them, right? This is fine, no problem. Then, why can you directly include it here? You can see that in our module, it's a bit convoluted. This part is very convoluted. I explained it very carefully. Why can you directly include this location? You see, this location comes down from this location. Then it goes to this location. It goes to this file, right? This is completely fine, no problem. Why can you directly include this public location? It's because of the module here. A public header file include path is written here. So the module name is specified at this location. Then after coming down from this place, you can directly include it. So here a property library folder is included here. Then in the case of text64, we first need to get this label. The absolute path of label P in there. Okay, no problem. It is under this path. Then next, he puts the DL name in. After putting the DL name in, you must put it in the right place. So here, he uses this runtime to do a dynamic copy. This runtime deploy. So this part, it is in this path. Where is this path written? It is written in this location. You see, it is written to this location. But let us Win64. You see, third party. This thing, Win64, it is in, it will be during packaging. Bake this thing in. Okay, there is absolutely no problem with this point. Okay, so for the entire project, I finished explaining it to you. That is to say, don't look at these things for now. It's actually like this. That is to say, in here, we find this project, seller party library, then in this source, and then here under seller party. Don't look at any of these. These things we need to delete later. What we mainly care about is these two files. They must be included during compilation. This thing, when you use it, must be copied to a specified path. At the same time, your header file is this one, okay? So only these two files are enough. You don't need to look at the others, okay? Then, the biggest problem here is you need to manually put this thing. So this thing, manually paste this thing. Paste it under which path? Paste it into this location of the plugin. If you haven't done this, then when you package it, you won't be able to find this DLL, and then problems will occur. So at this point, we need it to be automatically copied over. Because one operation we often do is that we like to delete these two things after deleting them. The next time you go to this gallery to find this X library D, it won't be there. So this is the plugin, the first common problem. So this DLL of yours can be found. Okay, then congratulations. Your applied code is scrapped. Once someone deletes it, you won't be able to use it anymore. That's what it means. Okay, so we're actually done here. Then let me talk a bit more about this. What am I going to talk about now? Talk about this. We deliberately emphasized earlier that we didn't cover this part. Why didn't we cover it? It is like this. It has this thing. What exactly is this thing? We opened another OS. This is actually a traditional C++ project. Here, by writing code like this, it compiles libpng and the web. Then it copies them into our project. You can write another method here. Then you can make another call. You understand, right? You can click compile here. After compiling, look at this path. Take a look. What is this path for? Xolution debug. We found this x64 deb. Right. You can see this part corresponds to its time. It was just compiled. This is essentially the production process of the third-party library. These things are part of the production process of the third-party library. Is this for Mac? We won't worry about that. We only care about Windows. Okay, this is the header file. Actually, when you do it, what do you need to do? You need to take this. Let me find it for you. You need to put this. Let me see where this header file is placed. Take a look. You can see that you need to manually copy this header file over. So, and that's the situation. Okay, so let's stop here. Actually, you're still feeling a bit confused, still unclear. This might have something to do with my explanation, because this topic is indeed quite convoluted. And in the next class, we'll guide you through writing this and running through this process. After this class, you should understand that you used a C++ project, and then the header files of the C++ project. Then compile and generate the lab and DLL, import them into UE5 for use. Then this import process must be fully automatic, cannot be done manually. Only then can it be ensured that it works in both the editor and the packager. Only then can it be ensured that here, deleting the batteries at will. An intermediate is fine, because many people's plugins cannot touch the batteries and intermediate. That is not correct. Okay, in the next episode, we will manually operate a third-party library.